Yes, I will be presenting this paper by the title of Investigation of Energy Loads in Different Window-to-Wall Ratio for Different Orientations of Building Model. And aims of this study, introducing and investigating building model dimensions, and giving the information for the different simulation and scenarios, giving detailed information about climate conditions of the ratio of the building, providing information about method and software used. The next one is investigating change of the building's loads via simulation in different window-to-wall ratios for different orientations. In conclusion, revealing the orientation and window-to-wall ratio with best scenario for reducing loads of the building in terms of providing proper thermal conditions for occupants. And we have into the introduction, energy is a challenging issue in developing countries which make new era in energy efficient architecture in contemporary architecture of these countries, such as Turkey that is dealing with energy shortage problems. This figure is about energy supply and demand changes in Turkey between the 1990 and 2007 years for supply and demand. And nowadays, it is encouraged to use computer-based simulations from well-known organizations to accomplish energy-efficient projects. It is accepted that making energy-efficient design decisions in the early stage of the building design process has the most influential and cost-effective results. It is also an undeniable fact that solar energy is one of the most important factors affecting energy consumption in buildings, which is gained via radiation, conduction, and convection inside of the building. In this study, the effect of different window-to-wall ratio according to different orientations on heating and cooling loads were investigated in the city of Istanbul. Given the conditions for this city, it is aimed to increase the energy performance of the building by determining the appropriate WWR or window-to-wall ratio and orientation in moderate humid climates. With effective use of controllable design parameters, it is possible to increase the indoor thermal comfort and reduce the negative impact on the environment due to energy consumption. What is the methodology? This research is based on modeling and simulating via Rhino 6 and architectural modeling program Grasshopper, that is a software inside of the Rhino. To parameterize the Rhino model, plugins named Ladybug 0.0.65 for examining environmental data and Honeybee 0.0.65 for energy simulation. And different WWR were selected on two opposite, as we know, two opposite sides in this figures as shown. Two opposite sides of the examined building model and the total energy loss of heating, cooling, and lighting were calculated and compared via energy simulation by rotating 45 degrees on the central axis of the building. And the design model is considered an office building with dimensions of 10 to 10 to 10 meters and with 3 floors. The building has only 2 windows on 2 opposite facades. As determination of window to wall ratios that provide optimum energy consumption based on direction. Here we have transparency rates. We have alternatives, for example, 20-40%, 20-60%, 20 and 60%. That, as shown, steps of rotating the alternatives around their axis. And here, yes, we have another alternatives for 40%, 60%. Other alternative is 40%, 80%. The other one is 60%, 80%. And we have results and the discussion. In this figure, the comparative analysis was performed in 8 steps by changing the angle between the vertical axis passing through the north facade and the north axis. And energy consumption for example, energy consumption for the 20% and 40% WWR alternative with 8 orientation of the building is shown in this picture. In this figure, energy used for heating, cooling, and lighting in the different orientation from 0 degree without any orientation, without any changing, to 3050 degree is shown. Total energy used in without any changing, without any rotating, which WWR is 40% and 20% for the south and north side, is 268,067 kilowatt per hour, whereas in 2070 degree with WWR 40% and 20% for the east and west sides, respectively, is 6,876 kilowatt per hour. In here we have effect, the picture, the graph shows the effect of different orientation for 20% and 40% WWR alternative. Here we can, as you see, we have results indicate that the effect of window to wall ratio according to the building orientation is undeniable in the building total energy consumption. As this graph shows, illustrate, the increase in window to wall ratio on the building facade increases total energy consumption in this building. Here, the graph is, we have comparison of the effects of WWR, or window to wall ratio, in different building orientations on energy consumption. Assuming the window wall ratio remains constant at 40% on the opposite side of the specified facade, the building decreases in the maximum amount of the south sides of the building and reduces the minimum amount of on the north side of the building. However, in the northwest and northeast sides, when the window to wall ratio is increased from 20% to 60%, the heating load of the building increases. Here we have 2 graphs. The left one, both of them is for cooling load, comparison of the effect of window to wall ratio in different building orientation on energy consumption. Regarding cooling, it's about the cooling load, and In this picture, we can see the total. The left one shows the total energy. Illustrate total energy consumption for each specified facade when assuming the window to wall ratio remains constant and 20% on the opposite side of the discussed facade. The effect of changing the WWR on the total annual energy consumption is different than the amount of the heating or cooling load. And according to the right one, the other picture, right one, the southwest side with 17.6% and the west side with 15.4% have the largest total effect, whilst the north side has the smallest total effect. And we have conclusion. I want to discuss conclusion in this picture, in this slide. The heating and cooling energy consumption values were calculated with arranging window to wall ratios in opposite directions as 20%, 40%, 20%, 60%, and otherwise by rotating in the main and intermediate directions. The results indicate that the most optimized alternative regarding energy consumption according to the functional and climatic characteristics of the building is south-north orientation with the window to wall ratio of 20% and 40%, which the highest rate of the window is on the south side. While the worst case is west-east orientation with an opening rate of 60%, 80%. Thank you.